Hi, this is Moin Arshad,
Hey, this is Pradeesh Krishnan.
and this is for the data visualization class of the summer of 2018. We focused our project on causes of mortality in the United States. So I'd like to kick this off and start off with explaining that we've done some analysis with a data set from the World Health Organization and identified some disturbing elements of mortality rates in the United States. And we'd like to cover some of the topics that we did encounter and share with our classmates the insight that we did derive from that. So to start off, is it time for a change? So according to the Centers for Medicare and Medicaid, national health spending is projected to grow an average rate of 5.5% per year and reach to $5.7 trillion by 2026. So we're definitely pouring in lots of money into the healthcare system in the United States. However, even though we've come a long way in terms of healthcare and preventative awareness over the last few decades, the population of the US still suffers from a staggering high PYLL, which is a metric for calculating the potential years of life lost. So in 2015 alone, according to the OECD, the Organization for Economic Cooperation and Development, the US had a PYLL of over 14,000. Now that's pretty bad. That basically just means that the number of years that they expected the average person living in the US would have lived was cut short because of an unexpected mortality that occurred. So the higher the number for the PYLL, the more concerning that is. The US came somewhere close to number 3 and from the top of that list with the highest PYLL. So why is it that the US scores such a PYLL that's so much worse than the other OECD countries? Is it due to the 35% US population obesity rate? Is it lifestyle habits, the condition of healthcare administered, or even the accessibility of healthcare due to costs or lack thereof? So that begs the other question, what can we do about it? So, historically speaking, if we were able to identify trends that affect the major causes for health concerns in the US, we can take action and target preventative care in the areas it's needed most. So, by utilizing the rich collection of data provided by WHO, World Health Organization, we can not only determine the primary causes of mortality in the US, but also identify the risks presented to various classifications, such as gender and age groups. So our project, titled Causes of Mortality Analysis, is a project that's focused on leveraging the mortality data set provided by the World Health Organization. And we focused our project on gathering insight to create an effective control strategy in order to reduce the mortality trend in the future. Or at the very least, if we're not able to reach at a national scale, this project can be used to raise awareness on the leading causes of death and encourage the members of the audience to really think about what risks they're already exposing themselves to at an individual scale. So the primary goals we'd like to address is the identification of which US health statistics prove to be the highest included risk for mortality, whether or not we're able to identify the primary health concerns or causes of mortality. We'd also like to target preventative measures that may be actioned to reduce the number of people who have lost their lives to these areas. So essentially, just to get people really thinking about, hey, these particular causes of mortality shouldn't really be this high. What could be the factors that are really feeding into this metric here? So, of course, research has already been done out there. This is definitely not a new field, and it's been around for decades. In fact, this has been a topic that's been heavily studied, and it's part of the reason why we have such a rich data set to work with already from the WHO and from the CDC. In fact, the WHO and the CDC regularly publish their own data sets to suggest data-driven actions and recommendations for the general public. And the OECD also publishes analysis which supports and supplements information for the United States health standing in comparison to the rest of the world. So here, if we take a quick look, these are just a couple of visualizations that are already floating out there. The one to the right is provided by the CDC, which basically covers the It looks sort of like a trend downward chart of the death rate and by the year it is. So the further along or more recent we get, the better the mortality rates are getting, reducing. But that still means that there's a lot of mortality trends to analyze there to try to get this even lower. The chart to the left basically describes how the US population is in standing with the rest of the world in terms of specific key metrics, like whether or not how many populations in the US have asthma, or if there's obesity in adults. So as you can see, that's sort of closer to the edge of that, meaning that we are definitely the leaders in the world for having the highest rate of obesity in the country. So other trend analyses that are out there. So temporal mortality trend analysis for the US, that was done between the years of 69 to 13. And that was performed from the National Vital Statistics System, which is a subset of the CDC. And this basically found an overall decreasing trend in the death rate, as you saw in this diagram here. However, the rate of decrease had slowed down for heart disease, stroke, and diabetes. So this is another look into some of the other visualizations that are out there. Again, this is another trend line of average death by the years that are out there from historical to current. And the first chart on the left covers both genders, male and female, along with the average of the two. And then the one to the right also covers individual illnesses, so classifications of those issues against the year and the total death count for that. So our data set, we focused on using the World Health Organization data set, which is one of the largest recognized organizations that provides a large-scale data set that covers health statistics and mortality causes. So it's a compilation of mortality data by age, sex, and cause of death as reported annually by members of the state from each of their civil registration systems. So we've extracted the mortality data for the United States from the year 2005 until 2015 for this project, and the description of this death cause is derived using the ICD, International Cause of Death Codes. Without any further ado, we'd like to jump right into our visual insights though. Before we begin, at a very high level, these are the top 10 causes of death in the US across all ages from the years 2000 to 2015. And we've tried to dig a little deeper into these causes and extracted a lower level cause of death and use that for the visualizations. So we're working a little bit more of a granular level, and we're going to show that at a bit more rolled up level. So this is an example of a word cloud, which shows the top 10 diseases out there or the leading causes of mortality in the US. And as you can see, heart disease immediately pops out at you, along with neoplasm lung, which is essentially lung disease or lung cancer. Alzheimer's is another big factor as well. STEMI infraction, another one. So dementia. This sort of groups the frequency of these occurrences by the size of the font. We'll see more details of these as we go along. So this horizontal bar chart shows the total death for the top 10 causes across different age groups from 2005 to 2015. And based on this chart, heart disease is the top in the list with 2,861,639 deaths. Again, this is for that decade-long period. Malignant neoplasm of breast is last in the list with 455,154 deaths. This is another view into that data, and this shows the total death for the top 10 death causes for male and female. And based on this chart, male deaths are higher than female deaths in this data set, and both genders have heart disease as a leading cause for death, as you can see right at the very top here. So this trend analysis, it highlights the total death toll versus yearly period over the last 10 years per cause of death. This not only reveals the leading causes of death in the US, but also demonstrates the relationship between the causes in terms of mortality rates. So heart disease is at the top of the mortality cause list and also shows an interesting trend. This shows a decline of nearly 50,000 mortalities from 2005 to 2015, as you can see here. However, further down the trend analysis, we can see that the heart failure is beginning to rise by 2015. The second leading cause is bronchus and lung cancer, which is pretty interesting as well. This has a nearly consistent rate with little change in the 10-year period, this green line here. On the other hand, Alzheimer's is mostly seen in older people, has shown an increase and in the trend. And since this type of dementia arises mostly because of the genes, its preventative measure is a challenging question. And of course, chronic pulmonary disease is also related to lung and bronchus category. It's on the rise, nearly converging with lung cancer by 2015, this blue line here. Myocardial infarction is following a downward trend of 2005 to 2015. So this looks to be somewhat of a downward decline, but we do have other heart-related ailments that are raising the overall picture of heart health into the higher rates of mortality. So this is a stacked area chart, which shows the total death percentage across different age groups for the top 10 causes of death. As the age scale increases, the area under the chart changes for each type of cause. For example, pneumonia, as seen here in gray, has a much larger area under the age of 25, meaning pneumonia is responsible for a higher percentage of deaths under the age of 25. While after 25, the area is slowly decreased afterwards, indicating lesser deaths occurring to pneumonia as age increases. Another example is dementia, which is in blue, it's also seen only in mostly in older age groups, which confirms that this chart shows that after 70, dementia is stronger or more prominent than the rest of the age groups out here. It's another look at the same type of stack chart, but this is focused on the gender male. So as the age scale increases, the area under the chart also changes for each type. Chronic heart disease, which is in orange, takes up the majority of the area beyond all the other categories here. So it's the most prevalent mortality cause for males. Females as well, similar. We have malignant neoplasm of breast, which is essentially breast cancer, as one of the leading causes, but heart disease still overtakes that in the orange. So the total deaths of age for the top 10 causes, we're able, in this chart, we're able to see that the majority of these mortalities strike during the age group of 85 to 89, which is that, notice at this peak right here, where all the colors seem to spike. 85 to 89 also contains the peak mortalities due to dementia, Alzheimer's, STEMI, NSTEMI, myocardial infarction, which is another heart-related ailment, general heart failure, and pneumonia. 6 out of 10 of these top 10 mortality causes. Malignant neoplasm of bronchus and lung, in other words, lung cancer, is in an all-time high by the age of 70 to 74. And it's important to note that many of these causes remain dormant until we start to see an upward trend between 30 to 44 before heart disease and lung cancer can take the lead. And that's pretty consistent with when people typically start to go for regular checkups. And this chart seems to prove that. So this overall converges to 0 after 95 years of age because people typically don't live that long beyond that. So everybody dies, goes to 0. So this chart here shows the trends of death across different age groups, and it looks like the death for age groups is consistent, except for in the age group of greater than 80. It's possible that people live longer. People die after 80, typically due to improvement in medical industry. So regarding this chart, this shows the total deaths by sex and age group. And I'd like to point out that this is looking at a logarithmic scale in order to bring out the smaller age groups with not as enough or as many mortalities. So the infantiles, 0 to 9s, 10 to 19s, probably with 25s. This would not have been seen if we had just scaled it by the number of deaths there were. This is a radar chart, and also shows the leading causes of death. Just another quick view to point out just how prominent chronic heart disease is, which is seen in the bottom right, following, of course, by the bronchus and lung on the far left. So this scatter plot here basically just shows that for both male and female, the mortality rates are fairly consistent and in line with one another until the ages of 40 to 44, where they start to diverge. And then by the age of 85 to 89, they converge once again before splitting apart. So it essentially means that males will typically die faster than females, and then vice versa, because females typically outlive males after a certain age. This horizontal bar chart shows the top 10 deaths causes for all age groups, 2014 and 2015. And another look, heart disease is right at the top. As for top 10 death causes for infants between 2014 and 2015. And the top cause remains the same for both years, the discord of NB and low birth weight. So this temporal trend for the deaths has increased over the years, even with the advancement in medical industry. But I'd like to point out that this doesn't necessarily take into account the population increase. So results and insights, what have we gathered from these visualizations and going through this data set? It's that heart disease is the #1 killer in the United States, and lung disease being the second highest in male and female. So the ailments typically begin around age 30 and they peak around the 80s, the age group of 80s. And the top 10 causes of death remain the same for the year of 2014 and 15, with heart disease topping the chart, following lung disease. Overall, the female population tends to live longer than males, and the temporal trend for deaths has increased over the years, even with the advancement in medical industry. Infant death is reduced, but is likely caused by low birth weight, which remains the top mortality for infants. And in the last 10 years, ailments have generally either remained consistent in mortality rates or increased, with myocardial infections being the clear decreasal. But collectively, heart disease seems to be the main cause of mortality here. And with that, just a little focused insight into that. These visualizations really do reveal that no matter what direction we paint this in, heart disease is the leading cause of death. However, when examining the trend lines, we did see that decline from 2005 to 2015. But there's still the potential loss of life count that's still much higher than the majority of the other countries out there, which really begins to question, why is it that we haven't brought that count down lower? And there's no single specific reason that can be sort of credited for the work that has been done to bring that down, but it's believed it's probably related to the awareness that's now coming out around surrounding heart disease. There's fewer smokers, improved medications, research advancements, and of course, if you can identify issues early on and you live in healthier environments, then that is also going to go a long way. So this is in line with what we're hoping to do, is raise awareness of these types of risks out there. So what are some of the next steps we'd like to do to continue this project onward is to expand the existing data set that we do have to include race, income class, environmental factors, things that might give us a more rich insight into identifying key parts of or population subsets that are exhibiting higher rates or lower rates, what it is that's different about them, and dive into a more granular level of geography to isolate subpopulations that have a higher risk. So is it that heart disease improved because of the populations on the coasts and it still remains rampant in the south? That's something that we can sort of bring in once we bring a state or county level geography in. And of course, try to diversify the data set to include other domains that may affect these trends, such as healthcare costs. If the healthcare is too high, people are not going for preventative screening and they don't catch it in time. And we would like to expand this to pull in data from the other countries as well to view the US on a global scale and prove out those statistics of just where we stand comparatively. And well, I hope you enjoyed the presentation up till now. We have a few reference links at the end if you have any interest in going into some further reading. And thank you for your time. I appreciate it.